Okay, so this question has to do with topic 1.11, which is continuity at a point, and it says that let f be the function defined above. Which of the following statements is true? So just doing a quick vertical scan of my answer choices, I am basically noticing that I am looking for whether the function is continuous or not and why. So in order to be successful on this problem, I have to remember my three conditions for continuity at a point. First, f of a must be defined. Two, it must equal the overall limit, which means it must equal the limit from the right, must equal the limit from the left. Please ignore my sloppy and quick notation and bear with me there. So now let's check these one by one. So first of all, does f of a exist? Well, in fact, it does not exist. How do I know? Well, looking up here, this is only defined for x is less than 1, and this is only defined for x is greater than 1. We do not have it, neither of those have an equal, right? Neither of those are less than or equal or greater than or equal to. So actually, in this case, the function is not continuous because f of 1 does not exist. However, just for the sake of the lesson, let's go ahead and find these one-sided limits just so you can see how you would solve this if this was not the case. So this is going to be from the left and this is going to be from the right. So the limit from, actually, let's do the right first just because of how I wrote this out here. So from the right, if I went ahead and plugged in 1, I would get 1/2 times 1 squared minus 1. I'm going to actually write this as 2 over 2, anticipating that I'm going to need a common denominator, and then plus 5 over 2. So simplifying this, this is just going to be 1/2. 1/2 minus 2 over 2 gives me negative 1 over 2, plus 5 over 2 gives me 4 over 2, which simplifies down to just 2. Now let's do the limit from the left. This one's a little more simple. 2 to the first power is simply 2. So this tells us that the overall limit does in fact exist and is equal to 2. However, bringing it back around, this function is still not continuous because f of 1 does not exist. All right, moving on.